Hello students, myself Priyanka Goswami. In this session, we will discuss about the chapter Measurement of Circuit Parameters, Part 1 of the subject Electrical Measuring Instruments. Here we will study two types of AC bridges, Maxwell's inductance bridge and shearing bridge. Now Maxwell's inductance bridge. The connection diagram of the Maxwell's bridge is shown in the figure. It measures an unknown inductance in terms of a known capacitor. One arm has a resistance in parallel with capacitor, and it is easier to write the balancing equation using impedance. Here L1 is the unknown inductance of resistance R1. R1 is a variable inductance of fixed resistance small r1. R2, R3, R4, these are the three variable resistance which is connected in series with inductor L2, and C4 is the known capacitor. Now, for balance condition, R1 plus j omega L1 into R4 by 1 plus j omega C4 R4 equals to R2 R3, or R1 R4 plus j omega L1 R4 equals to R2 R3 plus j omega C4 R4 R2 R3. By equating the real and imaginary part, we can write R1 equals to R2 R3 by R4 and L1 equals to R2 R3 into C4. This above equation shows the bridges have two variables R4 and C4 which appear in one of the two equations, and hence both the equations are independent. Now, advantages of the Maxwell's bridges. The balance equation is independent of losses associated with inductance. The measurement is independent of the excitation frequency. The scale of the resistance can be calibrated to read the inductance directly. A wide range of inductance at power and audio frequencies can be measured. Now, disadvantages. The Maxwell's inductor capacitance bridge requires a variable capacitor which is very expensive. Thus, sometimes the standard variable capacitor is used in the bridges, and the bridge is only used for the measurement of medium quality coils. Now, we will study shearing bridge. It is one of the most important AC bridge, and it is widely used for the measurement of unknown capacitor. Here, C1 is the capacitor whose capacitance is to be determined. Small r1 is the resistance representing the loss of the capacitor C1. C2 is a standard capacitor. R3 is a non-inductive resistance, C4 a variable capacitor, and R4 is a variable non-inductive resistance which is parallel with the variable capacitor C4. When the bridge is in the balance condition, zero current passes through the detector, which shows the potential across the detector is zero. At balance condition, Z1, Z4 equals to Z2, Z3. So we can write small r1 plus 1 by j omega C1 into R4 by 1 plus j omega C4 R4 equals to R3 by j omega C2. R1 plus 1 by j omega C1 into R4 equals to R3 by j omega C2 into 1 plus j omega C4 R4, or R1 R4 minus j R4 by omega C1 equals to minus j R3 by omega C1 plus R3 R4 C4 by C2. Equating the real and imaginary part, we can write R1 equals to R3 C4 by C2 and C1 equals to C2 into R4 by R3. These equations are balanced equation, and it is free from the frequency. Now, advantages. Balanced equations are free from frequency, and number 2, the arrangement of the bridge is less costly as compared to the other bridges. Now we will study earth tester. Definition. The instrument which is used for measuring the resistance of the earth is known as earth tester. So the purpose of earthing is to protect the various parts of the installation as well as the persons working against damage in case of and the insulation of a system fails at any point. The purpose of an earth electrode is to ensure that in the event of overvoltage on the system due to lightning discharges or other system faults, those parts of equipment which are normally dead as far as voltages are concerned do not attain dangerously high potentials. So the earth resistance can be measured with the help of the earth tester or a mega earth tester, and it is essentially a direct reading ohm meter and a hand driven generator which supplies the testing current. Here we see the diagram. The earth tester works only on the DC because of the rectifier. The tester has two commutators placed along with the current reverser and rectifier. Each commutator consists four fixed brushes. The commutator is a device which is used for converting the direction of flows of current. It is connected in series with the armature of the generator, and the brushes are used for transferring the power from the stationary parts to the moving parts of the devices. The hand operated generator produces the direct current, but to eliminate the effect of electrolytic electromotive force or EMF, it is necessary to pass alternating current through the soil. So, to change the DC into an alternating supply, a rotary current reverser is mounted on the same shaft of the generator. The alternating current in the soil will produce an alternating drop in the soil, but the potential to be applied across the moving coil must be direct because the ohm meter in a moving coil instrument works on DC alone. So, for changing the alternating drop into the direct drop, a synchronous rotary rectifier is also attached in the figure, which is shown in the figure. Although the instrument is immune to stray currents, while taking readings, sometimes it will observe that the needle vibrates. This happens only at the instant when the stray alternating current has the same frequency as the frequency generated. For such occasions, either increase the speed of the generator a little or lower its speed. For measurement of earth resistance, two spikes acting as current and potential electrodes are driven into the ground at a suitable distance, that is C2, at a distance about 25 meter from earth electrode under test. P1 and C1 terminals of the meter are shorted and are connected to the earth electrode under test. First spike P2 is fixed between the spike C2 and the earth electrode, and the resistance is determined. Then this spike taken 3 to 4 meter near to the earth electrode, and then for the same distance near to the electrode C2, and the two readings are again noted. The average of these three readings is the required earth resistance. Thank you.